Welcome to today's demo from Introspect technology, where we show operating the Introspect tools using the Labview programming language. In this demo, we have our MIPI d-phy generator connected to an oscilloscope, and a screen of the oscilloscope is shown here, where we will illustrate live control of the generator using Labview. The next part of the demo talks about the construction of a Labview program itself. So the Introspect tools operate using a runtime Python environment, and generating a Labview program to control our tools really starts with downloading a Python toolkit that is readily available over the web, and then setting it up for enabling a handshake between our Python runtime engine and the Labview engine. So to do this, there's a simple setup step that has to be taken, in which a simple Python program, a script rather, is supplied by Introspect to allow for the setup. And once this is done, the entire programming flow is done within Labview. So in this slide here, I show an example of a simple function that does nothing but call a MIPI d-phy generator setup command. So this is the first function that you would typically do when you're setting up the generator to do receiver testing. But then after that, we could go into another function that is a bit more sophisticated, and that is typically used in CTS testing, where you have a loop that checks on a pass-fail condition for a device and branches based on that condition. So this, at a glance, is an illustration of how the Introspect tool is programmed within the Labview graphical programming environment. We will go ahead now and actually run the tool. So I will minimize this window here and go into our run window of Labview. So this is our simple setup that we have done, and we will look at the scope on the left-hand side. So the first thing we will do, as I mentioned, is we will run a generator setup command. So we will just click on that, and this will start the generator. So now on the scope on the left, we have initiated a continuous streaming of a MIPI d-phy transmission that is typical of CSI or DSI. If I zoom out on this graph here, we will start to see short packets, long packets, and then if I keep zooming out, we will see lines as well. So this is a complete MIPI d-phy transmission that has been executed within Labview. The next step is to show control flows within Labview that we have programmed, and the best way to do that is to illustrate an example of a CTS test. So we will zoom in a bit on the LP waveform here, and then we will click on the Labview program run. So the first thing that the tool does in our demo here is it sets the LP voltage in test 2.1.1 and then queries whether the device has passed or failed. This step, of course, could be completely automated. We're using it manually here to illustrate the flow. So I will click yes, and we will see the LP level gradually shift downward. So keep an eye on the left side of the screen as I click yes, and we will see the level keep going down. One more time, the level has gone down, and one more time, the level has gone down. So this is the typical flow for test 2.1.1. At some point, the device will stop receiving data as expected, so it will return a no to the pass query, and the Labview program now returns the LP level up to the 1.1 state. So this would be a very simple demonstration of how we could use the Labview programming environment to not only control the Introspect generator, but also create complex programming loops that are typical of CTS testing. We can go ahead now and run another test for illustration. So we'll test 2.3.2. That's a HS amplitude test. So you can see that, again, the tool started with a large differential swing here. If I zoom out a bit, we will see that the swing on the pattern is quite large. Then we can go to the loop again, and so click yes, and the swing has decreased a bit. Click yes again, and the swing has decreased a bit. Click yes, and the swing decreases, and so on. So here's just a very quick demo of how to set up Labview for controlling the Introspect tools, as well as create a simple CTS framework really for testing receivers using Labview. Thank you very much for your attention.